you wanted to know what
Oh.
besides the souls of little children.
All right, 3-4, day 2.
So you like memorize people's orders?
Yeah, you get a cold cut and flatbread. What do I get? I can tell. What do
I can tell you what you
I don't
get.
know. You never come in when I'm working. I come in like every.
All right, let's review our formulas from yesterday. So we've got them handy on today's notes.
Your mom has it more than you do.
Big V is, first of all, what is it? What kind of velocity? Because we got two kinds now.
Linear.
It's linear velocity.
You have a 50% chance of getting that right.
Yeah, linear velocity. Do you remember any of the formulas from yesterday?
Yep.
R times theta over t, which came from S over t, because S equals R times theta, and then we had RW. So you really have 3 versions for big V. Because they won't give you just one all the time. The information they give you depends on which formula you will come back and use.
Why can't they not just give us the same information?
And then we had angular velocity.
Will it have to be rounded at the bottom?
It's a Greek letter and they do, but doesn't matter to me. Angular velocity was nice because we only had one form of it. What was it? Theta over time, because it was radians over time.
So let me guess, you're going to change that today?
Nope, that one's going to stay. And then our S. Our good old S was R times theta. You just took a quiz on that. But then the book gave you another formula. Do you remember it? It was the 4-letter one. RWT.
Yeah.
And it's coming from this one rearranged for T. If I multiply by T on both sides of this one, T times W equals theta, and they replaced it here. So those are all the formulas you're going to use in this section. All right, so we're going to start with a conceptual approach to angular velocity. Can you find the angular velocity of the, let's go with the minute hand on a clock. We're going to do all 3 of them. Okay, so looking at the minute hand on the clock, and we're going to talk about how fast it's moving, how fast that angle is changing at the center of the clock. Without me telling you what to do, tell me everything you know about that minute hand in terms of its speed. Anything. What do you know specifically about?
1 tick equals 60 seconds.
1 tick equals 60. I'm looking at the minute hand. So what do you mean?
It makes 360 degrees.
In how long? How long does it take that minute hand to go around the clock? 60 minutes. Okay. So the minute hand will make 1 revolution each for every. Do you agree with that statement? 60 minutes. Okay, now knowing that, we can figure out the angular velocity. Because what's the formula for angular velocity? Theta over time. What's theta? Radians. I know this thing turns 1 revolution every 60 minutes.
6.7.
Yeah, exactly, though. How much?
2 pi.
Exactly. 1 revolution is 2 pi radians. So this 1 revolution here, I can call this almost theta, because I can figure theta out from that piece of information. So 1 revolution is equal to 2 pi radians. 1 revolution is 2 pi radians. So now I know everything I need to figure out the angular velocity. 2 pi is my theta. For every 60 minutes, what would that reduce down to?
Pi over 30.
Pi over 30 what? What are my units going to be here?
Oh,
Yep, I had radians and I divided by minutes, so radians per minute. Can you find, we'll call that part A. Can you find the angular velocity of the hour hand? So tell me what you know about the speed of the hour hand on the clock.
1 revolution every 12 hours.
Matt's got it. That hour hand, when's the next time it's going to be back at that spot?
12 hours.
Yeah, tonight when I'm getting ready for bed. About 22:11 tonight. So it makes 1 revolution every 12 hours. Can you convert that information into an angular velocity? I hope so. So what's my theta going to be? 2 pi time 12 hours. So my reduced answer,
5 or 6
radians per
hours.
hour. And then can you do the second hand all on your own? Try the second hand all on your own.
I can't believe that just happened.
I was really hoping we could get it.
I thought like hand number 2. I don't know why. I need to like use my calculator to look.
Did you get this?
Oh, it's the rather.
So the whole trick to these is knowing how long it takes the hand to go around the clock. 1 revolution every
720.
60 seconds.
Whoa.
What did you
Crap.
say?
Crap.
Take a look. I can see that red hand moving. It only takes 60 seconds to go around. The other two, they're moving too slow for us to see with our eye. And so then the angular velocity is 2 pi, because it's 1 revolution
Over 6
for 60 seconds, pi over 30
radians per second.
radians per second. The same value, but the units are, it's like saying feet and miles. You know, you can't really compare them. Okay, so if I asked you how fast the tip of that second hand is moving in terms of linear velocity now, how fast is that tip going around the clock? We're going to do that one.
Example 2.
Yep. How fast is the tip?
Are you doing like A, B, and C?
Nope. Of the second hand moving on our clock. Tell me what information you need to answer this question. Well, first of all, what are we trying to find?
Linear velocity.
The linear velocity. How fast is the tip moving? That's big V. That's big V. So if we look at our big V formulas, what do I know about the second hand? What's one thing I know already that we just figured out? I know the angular velocity. We know that. It doesn't matter that it's that clock or a bigger clock or a smaller clock. The speed of the second hand is the same on all clocks in terms of angular velocity. But how fast the tip is moving depends on something else. So I know that the angular velocity is, what was it? Pi over 30. Because we just figured that out. So if I look at my formulas for big V, I've got r times theta over t, s over t, and r times w. Which one would I want to use? So what else do I need to know? The radius. What is the radius on a clock?
Couldn't tell you.
It depends on the size of the
It does. On that clock there, we're looking at the length of the second hand. That's the radius. So let's estimate it. How long do you think that second hand is?
No, that's not the radius, because it doesn't go all the way to the edge.
Well, we're only doing the second hand, so we're only looking at that part that the tip of the second hand is making. So yeah, we're not going out to the edge of the clock. I'm only focused on the tip. So my radius here is the length of the second hand, not the radius on the clock. Okay, so how long do you think that hand is?
4.5 inches.
4.5? It doesn't
You're not
matter.
gonna have-
I don't know what we got.
Yeah, let's make
5
it 5.
inches.
All right, let's go radius is 5 inches.
We'll round up.
Okay? So that's what you needed to know, and I didn't tell you, but we're going to use the RW. So 5 inches multiplied by the, not that I need the inches there, sorry, pi over 30. And let's get an approximate value that actually means something to me, so I don't want to see pi in the answer. What's 5 times pi divided by 30? How fast is that thing moving? What is it?
0.5236.
0.52. That would be, what would my units be on that? We are going to count labels on the story problem. Yep, remember velocity is a distance over time. I had inches, and we had seconds here, because this was radians per second. So this would be inches per second. So it's covering about a half an inch every second on the clock. Justin?
What is W?
Angular velocity, radians per time. Okay, so today is where it's going to get a little more challenging. Let's see, we did that. Now I'm actually on to the day 2 notes. All right. I know, but I didn't finish day 1 yesterday. No, we're just continuing on. This is compared to what I had originally for day 1 and day 2. It's all good. This is day 2. All right, I've got a tire.
What are radians again?
Radians an angle measure. You can compare it to degrees. Tire that has a radius of 15 centimeters. Rotates 40 times per minute. Can you find how fast the tire is moving? Okay. It's all about looking at the labels and seeing what's given to you and what we're trying to find. First of all, how fast the tire is moving. What am I trying to find? Which velocity?
Linear.
Big V. I'm trying to find big V. 15 is giving me radius. Rotating 40 times in each minute.
W.
Is it W?
I feel like that's velocity. No.
It's like a velocity, but W is radians per minute. I've got rotations per minute. So you can break it apart into 2 separate things, or you can keep it as a single unit. I'm going to show you both ways how you can think about it, and then go from there. If I break it apart, my per minute is my time, 1 minute. This rotates 40 times.
We're going to use the double theta over.
This, I don't call this theta, but I call this almost theta, because if I know how many times it's going around, can I figure out those radians? Every rotation is how many radians? So I call this almost theta. how do I turn 40 rotations into radians? Each one is 2 pi. So to get, every time I go around, that's 2 pi, correct?
80 pi.
So this, to get theta, I'm going to do it off to the side, theta actually is 40 times 2 pi, or 80 pi. So I've got V, R, theta, and T. Do you have a formula that relates those three? Yes. V equals R times theta divided by time. R is 15. What did we figure out the theta to be?
80 pi.
80 pi. And the time was?
1.
Per minute is 1 minute. So I got whatever that comes out.
Do you want to live pi on the answer?
Let's leave pi visible.
1,200.
What is it, 4,200?
1,000.
1,200 pi. What would the units be if this is a linear velocity?
Centimeters.
You need a distance and a time. What was my distance unit in here? Centimeters, and my time unit was minutes, so centimeters per minute. It's not too bad if you break it apart. You could have thought of this as one value, 40 rotations per minute. Then I would have called this almost W. Come on, I'll get the door and let her in.
Would you be mad if we did 1.2 meters per minute?
1.2. Oh, switch it over? Well, you still need the pi on there.
Wait, that can also be.
Yes, but if you think of it as almost W, you still have to multiply by 2 pi. So it's 40 times 2 pi, but now it becomes radians per minute. 80 pi radians per minute, where this was just 80 pi radians. Either way, you're multiplying by 2 pi. Here I broke it apart and just said I had the 1 minute. Here I just kept it in with that, so the 1 didn't affect anything. I like to break it apart in case we've got to change time values later on. So I suggest breaking it apart into the two things. All right, try another one.
I thought, what did that occur?
Okay, I've got a wheel that's making 80 revolutions.
Paper always?
Yep, 80 revolutions
Okay.
each minute. The radius of the wheel is 6 centimeters. Can you find how fast it is moving in, I must have it zoomed in a little. There we go. In centimeters per second. What do you need? Nope. It was going to be something, but it was supposed to be a period. It was going to be a question mark, but then I realized it wasn't a question. It's not even a complete sentence, so I don't even know why I bother. So, okay. So it's all about digging in here and seeing what variables they're giving you. First of all, decide what you're trying to find. What am I trying to find? Big V. 80 revolutions. What variable can I get knowing how many revolution means it's turning? I can get theta from that, right? So I like to, anytime I'm given revolutions or rotations, I call those almost theta. And I'll find it down off to the side what theta actually is. Each minute, there's my time. Time is 1 minute. Do you see any red flags in the problem? Where's the red flag, Austin?
They want centimeters per second.
per second. Minutes. So we do have a red flag. I don't have a red flag on the units because my radius was centimeters. I'm trying to find centimeters, but seconds is what I want. Minute is what I was given. So there's a red flag. I call those red flags. Okay. So off to the side. I need to find theta before I get started. How do I get theta? 80 times 2 pi. So my theta actually is 160 pi radians. My time, what am I given? 1 minute. What do I want?
Second.
So what's 1 minute equivalent to? I'm going to be using 60 seconds. And I'm looking for, and I know the radius. Radius is 6, so I don't have to change anything there. And now I'm ready. Now I've converted all my variables. Now it should seem very easy. Big V equals R times theta over T. 6 was my radius. Theta was 160 pi. Time is now 60 seconds. And now it's calculator work. Keeping the pi visible. Oh, I might be able to do this. 1, 10, 16 pi. Now give me a label. Oh yeah, centimeters per second. I gave it as a label. So if you take your time and you take it variable by variable, turn into what you want, they aren't bad. We're good? I'm going to go, I have 2 more, but I'll just do 1.
Wait, what was the answer?
16 pi. Centimeters per second. Okay. Here it is. Okay. See if you can tell what my picture is here.
Circle.
A thread.
Oh, a spool of thread. Very good. There's my thread. What do you need? I'm going to pull the thread off the spool, and the spool is going to spin. Spin, not spit. Okay. This spool is moving at 59.4 centimeters per second. It makes 152 revolutions per minute. Can you find the radius of the spool? Okay. Label what's given.
We already have our velocity.
What's the velocity?
59.4.
So what letter are we calling that?
V.
Big V. So big V is 59.4 centimeters per second. What's this 152? I'd like to break this apart. Revolutions. That is almost theta. So how do I get theta?
We're going to multiply it by 2. Pi.
Multiply it by 2 pi. And we get 304 pi radians
You're looking for your radius.
per minute. What's my time? 1 minute. Any red flags?
Minutes and a second.
Yes. So if I'm going to use this velocity, which is centimeters per second, I need to convert my minute, my 1 minute, into seconds.
60.
60 seconds.
Very good. Thank you, Lexi.
So the red flags, be looking for red flags. Minutes, seconds. And because I'm choosing to keep the 59.4, I have to be in seconds. That tells me to convert this one. And we're looking for R. Oh, one back in.
Are we giving exact or?
Nope, let's go approximate. Because the radius would never be given in terms of pi. So just plugging in now, there's the hard part, getting all that information right. Now it's the easy stuff like you were doing yesterday. So 59.4 is the V. Radius we're looking for. Theta is 304 pi. Divide by 60. So any way you can get there from here to get radius, you do it.
Multiply by 60?
You go ahead and do it.
Oh, I have the answer.
Oh, she has the answer. No, I want you to, because about radius, you wouldn't see something pi. So give me a, what are the units going to be on my radius?
Centimeters.
So let's give, how many centimeters is that spool of thread?
36.21. I got 36.8. Yeah, 36.8.
Why do I have 3.7?
We're so close there. Yeah, ooh. Ooh. Ooh.
Let's see. I've got 3.7.
I'll settle this.
All right, so what are you guys doing? Because you're all in the same ballpark and you're all wrong.
Do we have?
I got 3.7.
You're all wrong. You're all wrong. You're wrong.
I'm not. Okay, if I was going to do this, I guess I would, oh, I think I know what did you guys do? Tell me your steps.
I times by 3.14 instead of the pi button because I didn't know I had a pi.
That shouldn't make a difference.
No, I multiplied by 60.
Multiply by
and
60.
then I divided by 304 pi.
I know what happened, yay. 59.4
Yeah, plus 304 pi.
times by 60. And then you think, oh, I'm going to divide this by 304 pi. Because you see 304 pi as a single number. Take a look at what the calculator sees. What does the calculator see? That answer,
304
divide by 304, it does that. Then what does it do? Times that answer by pi. That's not what you wanted it to do. You wanted it to take 30,564 and divide by whatever 304 times pi is. I am so glad I had you try this.
Ooh, Alyssa, you were wrong too. Hey, but so are you. Oh, man, that one.
Okay? So if you've got a number, you needed it to work out 304 pi, so divided by that, you had to put in parentheses. Oh, I'm glad I had you try that all on your own. Oh, I am. See, you found a 3.7. Okay, you get to try something. Something here. This book.
What are we done with notes?
Yeah, we're done. Oh, thank God, we're almost at the end of the hour. You will be challenged on some of these. I'm not gonna lie. Friday, trig. Test is next Wednesday, Thursday-ish, depending on how these story problems go. We may need an extra day, another day besides Monday. Oh, page 134.
Wait, so is today just story problems?
Pretty much.
I'm okay with that. I hate story problems.